WMS supports advanced DEM delineation options. In this video, we will manipulate the default watershed boundaries by assigning map features such as road embankments, depressions, and known watershed boundaries to watershed delineations. A DEM and background image for an urban watershed have already been loaded into WMS. We'll start by running Topaz to compute flow paths and accumulations. And then we'll create an outlet on a stream. We'll then delineate a watershed with the Delineate Basins wizard. Because the DEM does not accurately represent urban terrain, the delineated watershed does not quite look like what we would expect. We will then turn on the flow directions. By zooming to the railroad tracks, we will see that the flow travels across the railroad. In WMS, we will use a stream arc to conceptually model runoff collecting along the railroad tracks. We'll then delineate the watershed with the new stream arc. Doing this changed the watershed drastically. When Topaz runs, it forces flow movement by filling all depressions when processing DEM elevations. Because we have a large gravel pit that will not realistically fill up, we will assign the low point to be a depression point. We'll then rerun Topaz. Next, we'll create an outlet at the low point, create a stream arc, and delineate our watersheds once again. We'll then use the WMS detention basin calculator to create a storage capacity curve for the gravel pit. Now, we'll use WMS to create time of concentration arcs. WMS does this by calculating the longest flow path in each basin. We'll then double-click a time computation arc to open its attributes. Various equations built into WMS can be used to derive the time of concentration. Next, we'll load a shapefile into WMS that shows the actual basin boundaries. We'll then use the shapefile to manually update the basin boundaries. Since manually changing the basin boundary changed the original time computation arc for the large basin, we will create a new time computation arc. We'll do this by turning on the flow distance contours, creating a node at the furthest point from the outlet, and creating a stream arc from that node.